Welcome. This is the 5th video in our series on apportionment. In this video, we're going to talk about the Huntington-Hill method for apportionment. This will be our last new method. In the Huntington-Hill method, like Jefferson's, Adams, and Webster's method before it, will involve choosing a divisor that works with the given rounding technique. And the intro to this technique is more involved than the other videos because the Huntington-Hill method introduces a new rounding technique. So let's discuss that first. And the first thing we're going to need is this concept of the geometric mean. It's another type of average. So typically when you're calculating an average, you add up all the numbers and you divide by the number of numbers that you have. That's called the arithmetic mean. The geometric mean involves multiplying the numbers together that you have and then taking a root based on how many numbers you multiply together. In the case of two numbers, you just multiply the numbers together and take the square root. So that's like the new definition of a new type of average. You have it for just two numbers. It extends to more numbers, but we just don't need that. So we only need the geometric mean of two numbers. Then the rounding rule for Huntington-Hill sets the cutoff point at this geometric mean between two numbers. So in conventional rounding, the cutoff point is 0.5. So if the number that you're dealing with has a decimal part that is more than 0.5, then you round it up, and if it's 0.5 or larger, you round it up, and if it's less than 0.5, you round it down. The Huntington-Hill rounding rule, the cutoff point is dependent on the number that you're rounding. So let's do an example where we round these numbers that are all between 5 and 6. So the rounding rule says, find the two nearest whole numbers, which are 5 and 6, and calculate their geometric mean. Let's do that. So we'll call it Huntington-Hill HH. It says, consider the geometric mean of 5 and 6, which is and then it's the square root of 5 times 6, which is the square root of 30. Bring our calculator in. So we need the square root of 30. It's 5.4772. And then more decimals after that. And so we say, okay, let's look at these numbers. We'll look at 5.423. And then if we're going to use the rounding method, we compare everything against this 5.4722. And so since 5.423 is less than 5.4772, we round down. So maybe we'll have a different color for rounds down to 5. Now 5.460. Again, you just look at the decimal part. 460 is less than 47, so we'll round down again to 5. Then 5.477 matches in the first three decimal places, but really after that there's only zeros. Right? Zeros at the end of a decimal place don't change its value. So maybe writing that 0 in makes it easier to see that this number is in fact less than this number, and so it needs to be rounded down. Then we have 5.478. And again, if you wanted to throw that 0 on there, you are welcome to. But you can see that this 478 is larger than 477. And so this number rounds up. And this is the first example of a number that would have typically rounded down, or typically being with conventional rounding rules. So this number rounds up to 6, even though the tenths place is less than 0.5. So here's an example of the Huntington-Hill rounding rule following a different pattern than conventional rounding. And then we didn't leave ourselves much room over here, so I'll have to write it up here. But 5.5 itself, the number that's normally like the boundary point, so the one where like the tenths place is the 0.5, this will also round up because it's larger than the cutoff point, which is 5.4772. So this will also round up to 6. So that's the Huntington-Hill rounding rule. In the next video, we will do an example where we use the Huntington-Hill rounding rule to apportion the seats in a representative branch of government to 6 states. See you there.